So we're talking about static electricity and charge and the different substances. And today I want to talk about how we cause an object to have charge. All right. The natural state of things is that everything has an equal number of protons and electrons, which we call neutral. So objects are neutral. The Earth, the universe is neutral. There's equal numbers of protons and electrons in the universe. But we can make the electrons move from place to place to make different places more positive if we take electrons away, or more negative. And we can cause small objects to have an imbalance, to give them a positive charge or a negative charge, depending on how many electrons have been taken away or added to an object. So I want to talk about that. There's 4 different ways of causing things to have different amounts of charge. But remember, neutral objects have the equal number of positives and negatives, and we have to make the electrons move to cause it to have an imbalance. So we have friction, also called triboelectric behavior. We don't need to know that name. We'll just use friction, polarization, conduction, and induction. All right. So let's talk friction. This is our typical thing that we're used to in the winter when you shock your younger siblings or something by rubbing your feet against the floor and touching their earlobe and making them jump, or touching the tip of their nose, because those are nice sensitive spots to really shock someone. The reason this works is because 2 surfaces of different substances are rubbed against each other, and one of the substances has more electron affinity. Electron affinity is the ability to attract electrons. And if the substances have different electron affinities, the one that has a greater affinity for electrons is going to take electrons away from the other one. So the one that has a greater electron affinity will become negatively charged. The one that has less electron affinity will become positively charged because it lacks electrons. Okay, that will stay in place on the surface of an insulator. Remember, conductors versus insulators. Conductors, the charges can move around and will distribute themselves on the surface. Insulators, they'll just stay in one place on the surface, so they can be kind of concentrated at one place on the surface of an insulator. So we have all kinds of different things. Now, atmosphere against the ground, this induces lightning eventually when it redistributes the charge to even it back out. That's what lightning is. Okay, silk on glass, balloon on hair. If you take a balloon and rub it on your hair and stick it on the wall or stick it on the ceiling, it's because the balloon has a greater electron affinity than your hair does. So it pulls electrons away from your hair, and your hair becomes positively charged, the balloon becomes negatively charged, and then it has the ability to attract positively charged objects, or be attracted to positively charged objects like the ceiling. All right. So the charge stays in place on the insulator. It'll distribute evenly on the surface on a conductor, and the object that charge is on will have a non-neutral charge. So if it loses electrons, it has a positive charge. If it gains electrons, it has a negative charge. All right. Polarization is more of a temporary situation. It only happens when things are near each other, and then it reverts back to its original situation. So I have an example of this, but and it has to be a conductor that has charge that can move on it. All right. So we're focusing on the next 3 slides. We're focusing on what's happening with this round object. And we're using a charge object, this red wand. The red means that it's negatively charged. And we're bringing it close to the conductor that is neutrally charged. So there's as many positives as negatives on this round circle. So when we bring that closer, it forces, in this case, because it's a negatively charged rod, it forces the electrons on the surface of that conductor to move to the farther side. That means that this side is negatively charged, this side is positively charged of the ball. All right. If this were an insulator, it wouldn't be able to do that. The negative charges would stay where they were. Now that would cause the ball to move away or to be attracted potentially. But what happens then is that this side of the ball, the positive side of the ball, is attracted more towards the rod because the positives are attracted to the negatives, so it moves towards it. All right. The negative side of the ball just orients the ball in that direction. But notice they're not touching. So as soon as that rod is pulled away, it becomes neutrally charged again. The negatives redistribute. Now this can happen at the molecular level. You talked about London dispersion forces in chemistry, where the larger molecules allow the electrons to move to one side of the molecule, so the molecule becomes a dipole, where one side is positive, one side is negative, but at other points in time, it's not a dipole. So that's because the electrons are moving around all the time. And if they're in the presence of an electric field, they are moved. Now, if this rod were positively charged, the electrons will be pulled towards the right-hand side of the ball. And so we'd have the opposite effect in the left-hand side being positively charged, the right-hand side being negatively charged. All right? But that's a temporary thing. As soon as that rod moves away, the electrons redistribute, and it's still neutral. The overall charge on that ball was neutral, but it had a positive side and a negative side for a time period. When we talk about conduction, conduction is when we touch something and it allows electrons to transfer back and forth. So it's actually transferring electrons. When we talked about polarization, the electrons don't move from one object to another. They are staying in the same object, but they're moving from one side to another of the object. All right? Conduction has to have a touch. And conduction will cause the objects to become similarly charged. In other words, I've got a neutral ball here and a negatively charged rod. And if I bring that negatively charged rod and touch the neutral ball, the ball will take on electrons and become negatively charged. Likewise, if I take a positively charged rod to a neutral ball, the electrons will go from the ball into the rod. And so they'll both become positively charged. So here we've got a negatively charged object, and electrons are going to flow in there. So if we look at that, first thing I do is polarize it, because again, this is a conductor. That has to be the case. So those move around. And then I bring that charge rod closer, and the electrons, some of the excess electrons go into the neutrally charged ball because they're attracted to the close by protons. Now that they don't all flow into the ball. The rod stays negative, but not as negatively charged as it was before. The ball now has extra electrons. So when I move that rod away, the electrons redistribute, and they are now the same charge. In this case, both negative. All right. If the rod were a positively charged object, the electrons would move into the rod, but not so much that it would become neutral. It'd still be positive, but less positive, and the ball would become positively charged too. So that's what happens. And it's a transfer of electrons from an area where it has an excess of electrons to an area where it doesn't have as many. And it is kind of like leveling off water. All right, it'll level off at some point, and it won't necessarily gain more in one direction or the other, but it levels off, so they're equally charged. In this case, negative. All right. So if we want to charge something the same as a charged object, we touch the charged object to the thing that we want to charge. Induction, when you induce something, if you've heard of someone that's pregnant, have labor induced, they cause the body to have something happen. They cause the body to go into labor. They give a pregnant woman drugs to cause her body to think it's ready to give birth. When you induce something, you are causing it to occur, but not necessarily a direct link to it. So charging by induction happens when we have an object that can have charges move on it. So it should be a conductor. I should put conductor here. So electrons can move from it. And we ground that object. Now, grounding means it is actually put in physical contact with the earth in some way. The earth acts as one big sea of protons and electrons. A little gain of electrons at one point on the earth is not going to change the overall charge of the earth very much. A little loss of electrons. So it acts as a big reservoir of charge. So if we have a charged object that comes in contact with the earth, it's going to give off extra electrons to the earth or take on extra electrons from the earth to get more neutral or to get the opposite charge. All right. So in this particular situation, the order of things is specific and important to get it to happen. And here we get the opposite charge of a charged object. So now I have the same exact situation as what I had with conduction, but I want that ball to become positively charged instead of negatively charged. If I want it to become negatively charged, I'd just touch it with the rod. But if I want it to become positively charged, I have to induce a positive charge. If you have wireless charging on your phone or AirPods or anything like that, it is a induced charge. It causes them to gain, to charge up the battery by not having a plug-in, but just by being in the proximity of something. So that's the most common induction that we have these days. All right. So here's the same situation. I cause it to have a polarization. So I cause the charges to move back and forth on the object by bringing it close to it, but I never touch it with the charged rod. What I do is give it a path to allow the electrons that are repelled from the rod to go away into the earth. So that's what this looks like. This is kind of a wire or a person. And these electrons have gone into the earth, or what we call the ground. Now, if I move the rod away, the electrons will flow back into that and it'll stay as a neutral object. But if I break contact with the ground right here, if I take that away first, now there's no path for electrons to go back in. So if I move that away, the electrons just redistribute on the object, but there's fewer electrons, so the object is now positively charged. So I got a positive charge, and this is still negative. So we can cause things to have the same charge or a different, the opposite charge, depending on whether we do conduction or induction. Induction, the order that we do things is important because we got to take away the path for electrons to travel. It works the same way if we have a positive charge rod and a neutral ball there. The positively charged rod would attract electrons to it. If we give a path for electrons to go into the ball, they're going to go into the ball from the ground. And then when we take away the ground and take away the rod, it'll become negatively charged because it'll have excess electrons. All right. So that's all I wanted to talk about today. 4 different ways of causing things to have charge: friction, polarization, which is a temporary type of thing, conduction, and induction. I hope that helps. We'll talk to you soon. Thanks.